Ampulla slides, first off, note that it is going to say Crista ambularis on the slide. That's the one you want to get for ampulla. Okay? There's all this stuff going on, and you're going to have to pan around like I am right now in order to find the very specific part that is actually the ampulla. Actually, I think I'm going to zoom out so we can find this a little faster. There we go. Okay. So, actually, I'm going to just leave it at this notation because I think we'll do all right with this. So, this entire thing, if we were just to put this up on the slide, this is the ampulla. Okay, this entire structure, ampulla. Now, the area that we're going to be focusing on and identifying parts from is this region right here. Okay, so kind of like a long-winded spiel, but I'm going to use the names as I go through it, but I'll actually go back and like identify them as I go. With the ampulla specifically, I think it's helpful if I explain kind of how it functions to go along with the different structures. So the ampulla in the Crista ambularis system, it's involved in equilibrium. So it helps you know up from down, and if you like, have you ever like been on a roller coaster or like the Gravitron or any of those that kind of throw off your center of balance and your equilibrium? The reason that happens is because it moves your head around so fast that it confuses this system. So the way this works, this entire compartment is filled with fluid. This little portion here called the cupola is actually a gelatinous-like substance. It's kind of like a gummy drop. Think of it as like a gummy drop that sits on top of the Crista ambularis. And when you move, the water and fluids inside of this compartment move as well. That movement is detected by this gel, and it moves with that fluid. There are sensory cells called hair cells that sit just on top of the Crista ambularis, and they stick out into the cupola, just like that. And when the cupola moves, the longest hairs move first, and then if it's a really big rotation, you have shorter hairs on the side that will also move. So that kind of tells you like how much it's moving. So basically, when those hairs move, that sends a sensory signal to the brain that your balance is off, or like up and down are now switched. You're standing on your head. Okay? So that's kind of how the system works, and kind of a really fun just like evolutionary fact about this too. We're not the only animals that have this system, but other animals use it in a very different way. So fish actually also have this same setup, but they have it externally. So obviously fish are in water. So instead of having a compartment of liquid that surrounds this, they have the ocean or the river that they're in surrounding them. And the reason that they don't bump into things, it's not because they have great eyesight, because they really don't. It's because they have these little sensory structures all the way down either side of their body. It's called the lateral line system. And when currents hit their body, they can detect them using this exact same system. So the cupola pick up the signal,